This is what you get if your green screen is not set up properly. To be frank with you, in my case, the acceleration was approximately 50 times. So how did we get here? Okay, jokes aside, here we go. I'm actually looking at a lot of lectures, video recordings, and I thought, well, we can shorten them somehow, but I did not know how. So what you can see here is a quick comparison of two video recordings. This one has the length of 1 hour 15 minutes and the other one has a length of 1 hour 10 minutes. Well, this 5-minute difference is what I managed to win. So, what am I talking about? I discovered a procedural editing software which is able to discriminate between silence and sound, but it does it very cleverly, and you can opt to keep the one or the other. And what I'm going to be talking about in this video is what it took in terms of time. Oh, can't, no, I cannot, but I have to. All right. So here is a demonstration of the original author. Let him explain what he does.
Not too bad, huh? I ran it on a 10-minute section. A typical 2x speedup would drop that to 5 minutes. But my algorithm shortens it further to 324. If you had 12 hours of lecture videos like we did, using my tool could save you another 1 hour 55 minutes, and that's enough time to watch The Room, and Bao, and the BFDI episode where they turn into puppets. Hi, so I want to show you how you can use this video editing tool. So after you've downloaded the file, it should just be one Python file, which makes it pretty convenient. Then you just open that folder up in the terminal, and you just run the command python jumpcutter.py.
So what he does, he is using a Python file and he writes his comments in this Python. We already downloaded it. Here we come. Here is his original jump cutter. So it takes a lot of variables, blah, blah, blah. I'm not going to bore you. Sometimes here at line 95, the magic actually happens. So it's creating a variable called comment and it assigns something called ffmpeg. And I was wondering, okay, he was mentioning something about ffmpeg in his video. So what I will need to do is I have to figure out what this ffmpeg does. It's one of those video editing tools which you can use freely, just like any other apps, but it only works in the command line, which means you have to use something like this. Some people call it a terminal. I don't know. It's a command line for me. The way it works, just come here, type cmd, and the window opens. It's already preset for the directory from which you launched it. That's why I like it. I can basically navigate through my entire folder structure. For example, I can look at what kind of files and directories I have from the perspective of this directory that I'm in right now. But there are other things. I can call the ffmpeg because I already have downloaded and installed it. The command is h. Yeah, that was the help function. So let's come back to Carrie's code. It calls ffmpeg as the program and certain functions, and it assigns it some variables. And then the magic happens. It takes this input file and it splits it into images. So he's not really programming everything in Python. He just builds an entire framework around this ffmpeg add-in. And I had to learn how this all operates to just actually understand what's happening. But hey, hold on for a second. This ffmpeg tool, it's using my CPU, this guy right here. And down here at the bottom, you will see something. It's a built-in GeForce GTX graphics card. That's the one we are going to be using. There was another author who actually perfected it a little bit and automated it.
I'll do this again for you to see. Just this file, drag it, and I'm going to do on this one, drop it, and yeah, so now what it does is it takes all of the frames, every single frame, and it converts it to a JPEG. You can see right here.
He converted the Python file into an executable, and it has an additional BAT file related, which contains all the commands I want to pass to this executable. I can define a silent time, an additional frame tolerance. There are some additional parameters. He enabled encoding with onboard graphic cards, so that's what we are going to use. So we have an input file somewhere here. It has a length of 1 minute and 21 seconds. That's a test file I have recorded. And with the currently preset parameters, let's have a look. So let me pull the video into the bat file as the author suggested. We will run it with GPU acceleration, and let's have a look what's happened here. You can see that it started extracting those images. It goes with 5960 frames per second speed. Here you can see the processed length of the video. We are at 35 seconds right now. So I'm gonna be waiting here for probably half a minute, just to wait for a minute's length of video to be extracted and images to be saved. At this point in the process, it is basically aligning the images according to the preset silence settings that I had. And this is the last part. So this is the one that gets some GPU acceleration. You can see it here, right? It accelerates. So what it does here, it's combining the pictures with the cut sound. This is generating the final file that we are interested in. And you can see that it kept 45 seconds of my original 1.5. Yeah, GPU usage is down, so you can see that actually only this last part of the process used this acceleration. So that's good. That could be good for short videos. Yes, it really helps. But if we come back to this lecture, it has a length of 1 hour and 10 minutes. Now, once you start picking images out of this video, it does not go with the speed of 3 times. It goes with a speed of 1.5, and I have already observed that this speed is not kept, it's declining. So unfortunately, you actually have to sit almost through the entire lecture just to extract the images. Then the second phase is pre-selecting the right images. That takes another more than 1 hour. Only the third phase is accelerated with the GPU. Just to save you these 5 minutes, you have to sit through twice the length of the lecture, plus however long it takes to render the final file. That seems like a lot of time wastage. But in the meanwhile, it managed to create something funny, which I will show you right now. So at least we had some fun with it. Okay, what do I think? Well, I think this tool is quite good. If you didn't notice, I'm using it to edit right this video. So let's see how it turns out. I don't know. As of now, the length of this preset is already 23 minutes. Yeah, for such maybe screen recording and random talk videos, it's probably useful. But if you want to use it to watch lectures and save time, someone would have to figure out how to use GPU acceleration on the entire process of the workflow. This process is running in Python. Python does nothing else, just some error handling, and is calling an application, a separate app called ffmpeg through the command line, and it's passing commands to this application. And the entire process is actually done via this ffmpeg. Now, ffmpeg is an app that natively does not support GPU acceleration, so I researched it online and learned quite a lot. For example, before I figured out that the whole workflow is outsourced to ffmpeg, I thought I can just use GPU acceleration over Python. And therefore, I learned you can use these JIT and CUDA libraries. They have to be installed first, of course, and your graphics cards, drivers have to be updated. CUDA has to be installed. Everything has to be communicating with each other. That was a pain in the neck, to say the least. And then I can run this script, which does nothing else, just basically sums up numbers from 1 to whatever 10 million, and it does it without and with GPU acceleration, and you can get a result which is basically duration, and you will see how fast it works. In my case, the acceleration was approximately 50 times, so I was really intrigued. Then I thought I will use this tool, and the jump cutter just ran into all kinds of errors until I realized that on this special line 95, he's basically injecting comments to ffmpeg and outsources the whole work to this plugin. And then I actually started looking into ways how I can GPU accelerate ffmpeg, and unfortunately it only works for the very last part. And as you could see, there was this clever guy who basically built executable files with the bat commands, and he made this process much more easier and efficient. But I still am looking for some clever idea how to accelerate the image extraction, which was very difficult and I did not manage. I always ran into all kinds of errors trying to do so. Well, that's all for me. I hope you liked it. See you in the next one.